Friends, welcome to my channel. I am Srinath. I am currently studying in Sri Venkateshwara College of Engineering, Bangalore. In this video, I will discuss about the numerical operator. First, we see content, define numerical operator and derive numerical operator. First one, define numerical operator in optical fiber. Optical fiber, the ability of optical fiber to accept light be the light gathering capability of optical fiber. Then sign of the acceptance angle, also called the numerical operator. Next, the expression for the numerical operator in the optical fibers. Let's see the consider how the figure will be drawn. Consider a light ray AO incident at the angle enters theta into the fiber. Let theta 1 be the angle of refraction for the ray theta naught. The refracted ray OB incident at a critical angle 90 minus theta 1 at B grazes the interface between core and cladding along BC. If the angle of incidence is greater than the critical angle, it undergoes total internal refraction. Then now if AO is rotated around the fiber axis by keeping theta naught same, and then the describes a conical surface through which the beam converges at the wide angles into the core and will be only be the total internal reflected. Thus theta is called the waveguide acceptance angle and also called the sine. Theta is also called the numerical operator. Then next we see this shown in the figure of the numerical operator. The refractive indexes of core and cladding medium will be the N1, N2, N1, N0, N2. Core will be the N1, N2 be the cladding. Also the medium surrounding medium will be the N0 respectively. From Snell's law N0 sin theta naught is equals to N1 sin theta 1, means the incident ray N0 N0 sin theta naught incident ray, the surrounding medium, is equals to then the refracted ray n1 sin theta 1 n1 and sin theta 1 at B. The angle of incidence is then the critical angle 90 minus theta 1. From Snell's law, again from Snell's law, n1 sin 9 theta 9 minus 90 minus theta 1, it means n1 is equals to sine in the form of sine 90 minus theta 1 is equals to then the n2 cladding for the n2 sine 90 n sine 90 minus theta 1 in the form of the cos theta 1 n1 cos theta 1. Next, then the cos theta 1 is equals to when the shift into the right side n2 by n1 from equation 1 sin theta naught. When equation 1, then the equation 1 n1 n0 sin theta 1, then sin theta 1 is also written as root of 1 minus cos square theta 1. Then put it equation for equation 3. Then using equation 2 and 3 will be equating sin theta naught is equals to n1 n0, then in root of 1 minus cos theta 1 is put into 1 minus n2 square by n1 square. Then next root of n1 square minus n2 square divided by n0 root, then put it into the equation 4. Next, if the surrounding medium is air, means n0 is 1, then sin theta naught is equals to root of n1 square minus n2 square divided by n0. Then n0 is 1, then remaining equation is sin theta naught is equals to root of n1 square minus n2 square. But sin theta naught is also called as the numerical operator. Then numerical operator is equals to root of n1 square minus n2 square in remaining equation. Therefore, for angle of incidence theta I, means angle of incidence equal to or less than theta naught, then the incident ray is able to propagate. If theta I is less than or theta naught, then sin theta I means sin theta of incident angle of incidence are less than is sin theta naught. Sin theta I is less than, then sin theta naught is put it into the root of n1 square minus n2 square. Then sin theta is also, then equation said that the numerical aperture is condition is propagation. Thank you.